Hello! Thank you for joining me today. I'm quite thrilled of being part of this very online, extremely online edition of PyCon AU 2020, and I hope you're just having a great conference so far. What's wrong with my multi-tenancy approach? This is the title of this Reddit post I found not so long ago of a person who is trying to create a multi-million-dollar app in Django by means of adding multi-tenancy to a previously existing single-tenant project. I felt quite identified with this post as I myself was in the same position a couple of years before, and it is truth that it's not just this Redditor and me sometimes lost in the ocean trying to understand what is wrong with the approach they have taken or are about to take when it comes to multi-tenancy in Python. As for me, well, I drowned for a little bit and eventually learned how to swim in this new ocean, but the fact is that now I have some answers to my own questions and I am in a much better position to answer myself what is wrong with my multi-tenancy approach. Just in case you are in the same boat of this gentleman and myself, and you know the feeling of waking up one day with a multi-million-dollar idea in your head for a multi-tenancy project in Django, and you are either considering whether to use Postgres or not, or already decided that to use Postgres schemas, then this talk is definitely for you. My name is Lorenzo Peña. I live in the other side of the world, called in Cuba. I have been a Django developer for over a decade, and as of late, this acquired taste of being a chaser of multi-tenancy beasts, as you can see in my picture to the right. The fact that you are attending this talk makes perfectly clear that you as well as I believe that Django is more than capable of lifting all the challenges that the upcoming decade can bring, especially any golden ideas for the future. So without any further ado, let's take a quick trip from multi-tenancy to Postgres schemas in Django. Okay, what is multi-tenancy? Let's do it through an example. Suppose customer red has a problem and you develop a solution, and the solution is working great, but now customers blue, green, and yellow have exactly the same problem. What to do? Well, given the fact that you have a problem already solved for customer red, you could either copy and paste that solution into multiple single-tenant solutions, or you could make the jump into multi-tenancy and actually adjust your code so that it is capable, single instance of the code, to serve the needs of all your customers. That is exactly what multi-tenancy is. And I'm sure you're probably familiar with these very popular businesses that implement the multi-tenancy model along with what would be a tenant in their own worldview. Let me just mention Slack workspaces and Discord servers because I'll be using those later on. Now, when implementing multi-tenancy, one of the major architectural challenges you have to make is how to structure your data layer. That is, what database architecture to use. There are typically three approaches: the isolated, shared, and semi-isolated. Let me just mention the last two. Shared is kind of the default one, is that in which you have a single database and your tables are scoped by tenant at the row level. And then the semi-isolated, which is the core of this talk, in which you still have a single database, but you use Postgres schemas to store your tenant data. Schemas have a specific concept within the Postgres worldview. They are a layer between databases and tables. They are equivalent to namespaces, and in the face of ambiguity, precedence is set through the search path. This means that if the search path is set to schema A, schema B, and public, which happens to be the default schema every database comes with, if you're looking for a table, it's going to be found in the first schema that actually has it. Now, in the typical schema to tenant configuration, every tenant usually gets its own schema, but also it's typical to use a shared schema to store data that is relevant to all models. Now, in Django, you don't have to do all this from scratch because there is a number of established packages that help you scaffold your project, and you can use Django Tenant Schemas, which is actually the pioneer package, and there is also Django Tenants with a number of improvements over the previous one. I also have my own experimental package, which I'm calling Django PG Schemas, and I'm doing some experiments there. Now, the three cornerstones of these packages is, number one, they all define a custom database backend in order to set the search path so that all subsequent queries can be done in the right schema. They also have a custom migrate command in order to operate with schemas because Django by default doesn't know what schemas are. And third, they have a custom database router with the allow migrate hook so that by working in tandem with the migrate command, the right models are getting placed in the right schemas. Now that we've made this super quick theoretical introduction, let me ask you something very important. Why would you pick schemas for your multi-tenancy project? And there is a number of valid reasons, each one varying in their degree of validity. It could be a case that you didn't know there were other options. Now you know that there are. Probably the sense of security that brings the fact that your data is going to be isolated at the database management system level is kind of compelling for you. Or perhaps you were running away from the burden that scoping all your queries would imply in a shared database approach. Or maybe you wanted to do some customization at the schema level or have an easier backup restore flow of tenants. Or, let's be honest, perhaps schemas were the hype technology by the time you were embarking in this journey. Truth is that this rose has some thorns, and unless you are quite aware of the thorns, as well as all the benefits that it may have, you are not making a fully informed decision. So in this talk, I'm going to cover a little bit some of the most important thorns I wish I had known before embarking with multi-tenancy through Postgres schemas. That is, what is wrong with the multi-tenancy approach? And let's go into answer this by covering the short, middle, and long-term challenges of the approach itself. So let's begin by untangling the schemas and the relationship between tenants, schemas, and models. This is a question very interesting to ask. What is the Python representation of a tenant? Well, as an abstract concept, you can think of a tenant as a plain old Python object with a schema name. That is a schema that is going to be associated with a tenant. As soon as you make the jump into models, it's practically the same, except that you have to ensure uniqueness of the schema name across all tenants. Now, this means that all tenants are going to have an associated schema, but the opposite is not going to hold true. Why? Because we're going to have one private schema per tenant, but we're also typically having a shared schema to store data that is relevant to all tenants at once. So in this case, the shared schema is not going to have any specific tenant associated, and this distinction is quite important to understand. In your regular Django project, you must place all your applications inside the installed apps list in your settings. Now, as soon as you start using one of these previous packages, you are forced to split your apps between shared apps and tenant apps. Whatever you put in your shared apps is going to get migrated in the shared schema, whereas whatever you put in your tenant apps is going to get migrated in each one of your private schemas corresponding to each one of your tenants. Now, why do we operate here at the application level and not at the model level in order to gain a higher granularity? Well, the migrate command itself operates at the application level, so it only makes sense to speak the same language. Now, let me give you some examples of things that could end up being placed in each one of the different types of schemas. In your private schema, you're going to be placing most of your models, most of your core applications, all your 10 specific models, and you can also place some customizable catalogs that you can't afford to place in the shared schema because tenants need to customize them. Now, in the shared schema, you usually place the tenant catalog itself, as well as other read-only catalogs for all the tenants, or system-wide data, or maybe some cache aggregations of data you recollect from all your tenants, or high-volume writes, that is information or data that is prone to be eventually extracted from the data layer itself. It is also possible to have models duplicated and therefore hidden between private schemas and shared schemas, and this is the case of the Django migration table itself, or content types with some known side effects or other meta models. This is no problem at all because the search path makes it so that each one of the tables can be completely found depending on the scope you are operating. Now, one interesting particular use case of placing applications into different schema levels is where to put users. And here comes another very important architectural decision you have to make. Because on one hand, you could have users that are bound and constrained within the context of a tenant, and on the other hand, you could have free users that could be associated to multiple tenants at the same time. So the former is the typical case of Slack, where you cannot even log in before specifying a workspace first, and the latter is the case of Discord, where it's perfectly okay to exist as a user even if you're not associated with any specific server, or even if you have multiple servers that you are associated with. If you're going to have users, bound users, the Slack style, well, you have to place them in your private schema, and you have to know that you will require an active tenant to be previously set before even being able to query your users. And of course, don't forget to use face masks. And if you're going to have free users, the Discord style, well, you place them in the shared schema. And remember that in this case, you will require database binding in order to know which tenants these users are associated with. Now, there is an interesting side effect, and it's database sessions. If you misplace your database-backed sessions in relationship to your users, this would be a source of leaking authentication. So the advice is that sessions must be equally strict or even stricter than users themselves. And the general advice is to actually keep them together with users to not have any worry at all. When you are playing with schemas and applications in the early stages of your project, it's perfectly okay to make a mistake and misplace something. So what to do if this is the case? Well, let me tell you that since we are using the allow migrate hook of the database router, all your migrations are still being recorded as being applied on every single schema. If you take a look at the Django migrations table of all your schemas, you will see that all migrations are there, even if the models are not. So the only way to fix this is to actually unapply and therefore reapply migrations differently. The general strategy is to unapply migrations of the app first, then you change the app to schema configuration that you did wrong in the first place, and then you can reapply migrations again. Now, try to avoid having sensible data before you actually stabilize your database and your app to schema layout, because when you have data that you cannot afford to lose, this becomes a little trickier. As soon as you have learned how to untangle the schemas in your head and in your project settings, then your own project is ready to take off, even if not so gracefully. And now the plot thickens and you are welcome to the middle term challenges, which get quite interesting. The first, or one of the first things you're going to notice is that as you incorporate new tenants, you will see that your tenant creation process is rather slow. And why is that? Well, because schema creation implies running all migrations from zero in your newly created schemas, and you know that your migration story of your project is not necessarily optimal every single time, so this is going to take some time. Not just that, if you have additional data that you need to initialize in your schema, this could also incorporate time to the mix. So the packages offer you this other way of creating new tenants, which is actually provisioning a special schema that you can clone instead of creating a new schema and running all migrations. This is not the default option on the packages, so you just need to learn how to operate with this and keep the special schema up to date in structure and the initial data. But you know what else is going to be slow? Migrations, mate. Yes, and this is something that you don't get warned about when you use one of the packages, and probably you don't even understand until it bites you. But the truth is that yes, migrations are a slow process, and the more tenants you have, the slower they will become. And the reason is that, remember, we are now using schemas, so it's like having tiny databases inside a single database. Imagine when you reach hundreds of schemas or thousands of schemas. This is going to be a time-consuming process. And of course, there are some strategies to reduce the time. But the fact is that no matter what strategy you use, migrations are still going to be slower than if it were a single schema in a single database. So, in order to reach the Zen status of zero downtime deployments, you're going to have to solve the problem by code. Imagine that at some point you're going to have a code updated and some of your schemas are going to be already migrated while others are going to be still pending migration. So the only possible strategy is to make your code resilient for this case that is going to happen. And the culture to have in your development team is to actually embrace multi-phase deployments, always make migrations reversible, and to be prepared to reverse migrations, because you are going to have to reverse migrations more times than you probably imagine right now. So the general strategy for these multi-phase deployments is to first change the code to handle both old and new database structure so that it doesn't explode. Then you can mutate your database and make sure all migrations run on all your schemas, and only after that step has completed, then you are free to remove all the safeguards and keep the code for the new database structure alone. But this muscle takes working out, so you better work out multi-phase deployment muscle as much as you gotta be working out the Friday deployment muscle. Yeah. There are other middle-term challenges that we don't have enough time to cover in depth, but these are data recollection across tenants to feed your enterprise dashboard, for instance, or running a backup restore flow when your users are placed in a shared schema, or maybe after some time you want to play with unique general purpose tenants like a master site, a blog, or the help center. But if you are worrying about these problems, then congratulations, this means that your actual project has lifted off and is actually very nominal in its ascent. Now you are ready to start worrying about the long-term things, and let me ask you, what if you're now having more tenants than you initially imagined you could have? What if what you initially thought would be a multi-million-dollar idea is actually becoming a billion or $1 trillion idea, and you actually creating the next unicorn? Well, these are good problems to have. So let me speak a little bit about the size of the behemoth you are creating. In case I haven't made this pretty obvious by now, let me just tell you that for every new tenant you bring on board, you're actually increasing the number of tables you have in your database. So if this pattern goes on and on, how far do you think you can get? Well, let me tell you, if you dig in the Postgres mailing list, you will eventually find this notion that there is no practical limit on the number of tables a Postgres database can have, and that's true, but one is the practicality for Postgres developer and the other is the practicality for your terms. So yes, there is going to be a practical limit, and it's going to come in the way of an increasingly degraded performance of your database operations. Now, there is no telling in when this is going to start happening, but based in the empirical notion that 1 million is a scary number of tables to have in a single database, let me give you this formula called the scary number of tenants, which is 1 million divided by the tables you have per tenant. Warning, I am not saying that 1 million is going to be the straw that will break the camel's back, but this could be very useful in order to calculating how many tenants you need to have in order to start worrying about these kind of things. And please look here that you don't need a lot of tables per tenant in order to reach fairly fast the scary number of tenants. So see that in the typical Django project, around 100 tables, your scary number is going to be 10,000 tenants, and if your project is between 100 and 150, it could get as low as 6.5 thousand. Is this going to be enough to make your multi-million-dollar idea thrive? Well, this is something you have to calculate yourself and decide. Truth is that this is not a Django-specific problem. This is more in the Postgres side, and this is a problem we found ourselves by using schemas in the first place. So this problem could probably be mitigated and your runway extended by doing some specific Postgres tweaks. But the bottom line here is that in reality, schema-related behemoths are not that massive. And this is not a good thing. This actually means that maybe the sky is not going to be your limit, and you probably have a ceiling above your head, and that ceiling is probably lower than you probably imagined. Now, the moment I told you that you might be incurring in performance issues with a single database, you probably thought, hey, why don't we shard? And this is okay. This is kind of the next step when you're getting really big. But let me warn you, sharding with schemas, this is something you don't find a lot of information out there in the internet. So it's either that people are not doing it or that nobody has returned in order to tell us how to do it. So we are entering here uncharted territories, and this is kind of the silence zone. So please, this next section could be more scientific speculation than experience. Facts come from experience. So anyways, we want to shard, right? So let's try to do it in the Django side. And the strategy is that, well, we're going to have to use schemas as the minimum decomposable unit because we are already using schemas for storing the tenant data. And then we're going to be routing physical shards in the same way that we are routing schemas. So if you remember the abstract concept of a tenant, now you only need to add the logical shard it belongs to, and then we translate the logical shard into a physical shard, which is actually the database. In this case, we are supposed to be using the database router, and we're just going to provide the physical shard as a default value for the database for read and database for write hook. This is something I am experimenting with in this pull request in my package, so feel free to chime in and see if we can figure out how to solve this problem. Now, there are some interesting theoretical challenges here and practical challenges is one of it is that we are now having multiple shared schemas, which initially we thought would be unique across all private schemas. So what are we going to do? Are we going to keep them in sync across multiple databases? Are we going to extract that data into a separate database and let referential integrity go? And this gets a little bit trickier when the users are placed in this shared schema, so this could be not so easy as you may have initially thought. At the end, probably sharding at the schema level is not a completely future-proof solution or an insurance policy for the project to continue ad infinitum, so don't be too enthusiastic about it. Now, it's time to ask ourselves the most dreaded questions of all. What if, after all, schemas are not enough? This is what I call the moment of chaos. Some people are going to tell you, hey, don't worry. When you find out schemas are not enough, you should have enough money to afford a complete rewrite of your project. And this is okay. This is a very practical approach. But let me balance that a little bit with this proverb. Sensible people will see trouble coming and avoid it, but an unthinking person will walk right into it and regret it later. So you can be practical, but this is not a decision to be made lightly. So just in case I have put you in this position right now and you're having a hard time deciding whether to schema or not to schema, especially since you still have this multi-million-dollar idea in your head, let's try to solve this dilemma in our conclusions by answering 3 very specific questions. Number 1, is multi-tenancy through schemas de facto wrong as a choice? Well, the answer is absolutely not. There is a number of perfectly valid use cases for using schemas where you don't even have to worry about the practical limits. As a matter of fact, there are a number of businesses already thriving by using schemas by means of using multi-tenancy. So the next question, should you use schemas in your next software as a service project? Well, it depends. First, you need to ask yourself and answer yourself, why would you pick schemas over other architectures? If you can convince yourself and you make your cost-benefit balance and schemas are winning, then by all means go ahead, but please round the numbers so that you know if you're going to have enough fuel to thrive with this approach. And the last question is, should you change your database architecture to something other than schemas if you're already invested in this? Well, we need to kind of fall back to the previous question. Would you have used a different architecture should your project have started today? If no, then okay. But if yes, my advice is don't panic. You don't have to tear down the whole building and then rebuild it from the ashes with a new architecture. There are still ways to smartly transition, and even in the worst case scenario, you can go for at least a couple of miles with schemas until you figure out a better solution and a transition plan. So the final word of advice is to actually make your informed decision with anything you may have learned today in this talk or anything you learn from your own research, but do it with a cold head. Not right after reading a blog post, not right after listening to this talk, because every project has different scope and different implications. So what applies to some doesn't necessarily have to apply to you. So let all the dust settle in your head and make your informed decision in calm. Just in case you finally have to decide to move away from schemas, here are some alternative packages you can use for the shared database approach, which is kind of the only alternative you have if schemas are not going to work for you: Django multi-tenant and Django scopes. And that's it. I sincerely hope that this talk has answered more questions than it has posed, but just in case it hasn't, and just in case you want to continue the debate, feel free to reach out. I'll be more than happy to continue the debate somewhere else. And that's it. I hope you enjoy the rest of your conference, and for the time being, hooroo!